This video presents the nomenclature rules for naming amides. This is also available in section 17.1 of your textbook. Amides are molecules that, like carboxylic acids, contain a carbonyl oxygen and a carbonyl carbon. Unlike carboxylic acids, which have an OH in this position and a carbon on this side, amides have a nitrogen in this position and a carbon on the other side. That nitrogen may either be an NH2, an NHR, or an NR2 group. To name an amide, we first identify the carbon chain length of the longest chain containing the carbonyl carbon. The corresponding alkane name will be modified by replacing the E ending of that name with amide. In this example, the longest chain is 3 carbons in length, which corresponds to the alkane propane. The E ending of propane will be replaced with the word amide. Amides can either be primary, secondary, or tertiary, and that designation is governed by how many carbons are attached to the nitrogen. In this example, there's only 1 carbon atom attached to the nitrogen, so this is a primary amide. This second example has a parent chain that is 6 carbons in length. It has 2 additional substituents attached to it at the 3 and 5 positions. Those are named out front and alphabetized. So 3-chloro-5-methyl. A 6 carbon chain is hexane. The E of hexane is dropped and amide is added. This too is a primary amide because the nitrogen is only attached to 1 carbon atom. When an amide is attached to a ring, as in this example, the alkane name retains the E ending, and added to the end of that name is the term carboxamide. So in this case, the alkane parent ring is a cyclohexane. Notice that the E is retained in this case, and the term carboxamide is placed at the end to indicate the presence of the amide attached to the cyclohexane ring. Also on this molecule is a tert-butyl group. The amide is higher in priority, and so we start by counting the ring at this position and count toward the tert-butyl group. It occupies position 4. The tert-butyl group is coming out of the opposite side of the amide on the ring, and so the stereochemical designation used is trans. This too is a primary amide because the nitrogen is attached only to 1 carbon. If the nitrogen is attached to more than 1 carbon, now we have to treat the name of the molecule a little bit differently. Now we have to name substituents off of the nitrogen as well. So if there is a substituent bonded to the nitrogen atom, that substituent name is placed out front of the parent name. If there's more than one, they're alphabetized. And to indicate that that substituent is attached to the nitrogen, an N is placed out front of that substituent name rather than a number. So in this case, the parent chain is 4 carbons in length, or butane. The E of butane is replaced with the word amide to indicate that that first carbon of the butane chain has an amide on it. The nitrogen has a carbon-containing group, in this case a cyclopropyl group. That cyclopropyl group is named out front of the parent name with an N that's italicized before cyclopropyl to indicate that that cyclopropyl group is attached directly to the nitrogen. This particular amide is a secondary amide because the nitrogen is attached to 2 carbons rather than just 1, as we saw in the previous examples. In this example, we find the amide carbonyl carbon and identify the longest chain to which it's attached. In this case, it's a 6 carbon chain, so a hexane. We drop the E of hexane, add amide to indicate that amide at position 1. And then we name any substituent on the nitrogen before the parent name. There are 2 in this case, an ethyl and a propyl, and those are alphabetized. Notice again there's a capital N that's italicized before the ethyl to indicate it's attached to the nitrogen, and a capital N before the propyl to indicate that it's also attached to the nitrogen. This is a tertiary amide because it's attached to 3 carbons and no hydrogens. Take a moment to try to name these 2 amides. When you think you have come up with proper names for them, continue playing the video to view the solution. This particular amide is a tertiary amide because the nitrogen is attached to 3 carbon atoms. The longest carbon chain that includes the carbonyl carbon of the amide is only 2 carbons in length, so it's referred to as an ethane. The E of the ethane name is dropped and amide takes its place. Attached to the nitrogen are a phenyl group and a methyl group. Methyl is placed first because these groups are alphabetized, and both the methyl and the phenyl have a capital italicized N before them. In the second example, there is a 4-carbon chain as the parent. 4 carbons is referred to as butane. The E of butane is dropped and replaced with amide. On the amide nitrogen, there's also a 4-carbon chain that's named as a substituent attached to the nitrogen, designated by a capital italicized N, followed by butyl. So N-butyl butanamide. This is a secondary amide because the nitrogen is attached to 2 carbons. Lastly, if amides are embedded within a ring, they are referred to as lactams. Lactams are named similarly to lactones in that the ring size is designated with a cycloalkane name, and the cycloalkane E ending is replaced with ONE. Now, instead of naming it a 2-oxa as we did for lactones, we name the nitrogen at the 2 position a 2-aza. So this is a 5-membered ring, or a cyclopentane. The E is replaced with an ONE ending, designating the carbonyl. We count around this lactam from the carbonyl carbon to the amide nitrogen at position 2, and that amide nitrogen is referred to as a 2-aza.